So hello, good morning to everybody and welcome at Politecnico di Torino. This is your first lecture at Politecnico di Torino. It is a lecture of Mathematical Analysis 1. And I'm your teacher of Mathematical Analysis 1. My name is Riccardo Adami. I write it here. And for me, as well as for all my colleagues, it is very easy from name and surname to derive the email address, and it is name.surname@polito.it. So I'm already talking about the use of the email, and of course you can use the email, but during the virtual classroom of Tuesday, I prefer you to use the chat of the virtual classroom in order to send me your question, and then I will answer. And please use the email address just for very short questions on specific argument. Otherwise, it is better to talk together in some way or to talk during the virtual classroom, okay? And in particular, don't send me exercises because I don't have the time to see your exercise. So you are 600, summing up all courses I have, so I cannot correct exercise for any of you. And moreover, don't send me something like administrative or practical questions like how to book a room and so on. For this sort of questions, always use the secretary of the student because, okay, I'm not really skilled in that kind of questions, so I risk to give you some wrong information and send you on a false path, okay? So, let us start, and I already sent you the schedule of the course, and now I can talk about the program of the course. So the program is a typical program of a calculus course, calculus 1 or analysis 1 course. So the main tool is given by the functions. What are functions? I guess all of you intuitively know what is a function. But if I ask you the definition of a function, probably we will have some surprise. Okay, it is not so elementary. It is not what everybody thinks that function is. So in order to get to functions, we have to introduce real numbers. And so this is the same as before. All of you know what is a real number. In real number, there is an integer part, there is a dot, and then there is a string, possible infinite string of digits. But what is the definition of a real number? It is not trivial at all. In order to construct the real number, we will have to pass through many things, and in particular to other numbers, so rational numbers. But before rational numbers, I will talk you about integer numbers. But this is not the basic block of our building, because before it we have the natural numbers. So we will start from here. We will start from natural numbers, okay? Natural numbers are numbers you use to count. 1, 2, 3. We add the 0 in this set. It is a sort of convention. There is nothing fundamental on it. Somebody uses 0 as a natural number, and others don't use it. But so it's a matter of taste. I like 0 to be there. And but in order to use natural number properly, we have to move other steps towards the basics, towards really the fundamental of mathematics. So Before natural number, I will talk you about set theory, the so-called naive set theory. I will explain you why I call it naive. And before naive set theory, we will need a very, very short introduction to logic. So we will need some elements of logic. Okay? This is the first part of the course, so to say, October, more or less. I hope to get to the function at the middle of October. And today, I will try to exhaust these two arguments. But before going there, let me move forward in the program, because we will introduce function and then we will introduce the idea of limit and then continuity. And from limit and continuity, we will go to a very, very, very important tool, which is the integration theory. Because the integration theory gives us the ability to compute the areas. I will talk a bit about that, a very, very, very short introduction about what is the sense of a calculus course, of an analysis course. But already from now, keep in mind that this is a very important problem, the problem of computing the area, and the answer is in the integration theory. Okay? Then from the integration theory, we will move to, in order to compute the areas, we will need another important tool, which is the derivative. So we will go to differential calculus. From differential calculus, we will learn how to study the detail of a function. This is made through the Taylor's theory, in particular Taylor's polynomials. And then once studied Taylor's polynomial, that are an extremely powerful tool, which allows you to compute limits in a very effective way, in a very easy way. And once we have Taylor's polynomials, we will go to so-called improper integrals. And at the end, after a short introduction to complex numbers, which are very important, however, we will close the course with a very quick and unfortunately very, in my opinion, insufficient look at the differential equations. Okay, this is the program of the course. As you can see, it is quite a long path, and I will try to give you the proof of everything I will tell you. This is the main difference between probably how you already studied the same topics in the high school and how you will study it here at the university, at the Polytechnic University of Turin. And so in principle, I should rigorously prove every statement I will say. For practical reasons, I will not have the time to do that, so I will choose. But however, I think I will prove a lot more than you know. And I want to stress this already from here. The main tool we will use is proofs, rigorous proof. So don't underestimate this point for many reasons. First, you are here to become engineers, and to be a good engineer you have to use logic. And proofs, learning to construct a rigorous mathematical proof is probably the best exercise in logic that you can have. So first of all, it is an exercise. Second, it is culture, because the mathematics is not just a collection of results. Results are very important, but it is probably more important how results are linked one to another, and in particular how they are proven starting from previous results. So again, proofs are very important from a cultural point of view. Third, but I guess you are not interested in this fact, we ask proofs at the exam. Okay? And now let's move to the exam. Here in Polytechnic we have 4 sessions of exams. Okay? The first section is in January, last week. Precise data are not officials. I will communicate you the precise data when we will have it. Second, in February, in the middle of February, traditionally there are 2 weeks, an interval of 2 weeks between the first and the second session. Third will be in June or July. So the end of June or the beginning of July. And last, it will be in September. In general in the middle, but it can vary. So you have 4 chances to pass the exam. Okay? This is much more than done in international universities in general. You have 1 chance or maximum 2. Here in Italy we have more than that. Here at Polytechnic of Turin we have 4 chances. And of course, if you fail 1, you can try the next one. There is no exclusion. Okay? And how the exam is made. These are the sessions. And then here we have the structure of the exam to be discussed. The structure of the exam is made of 3 steps. The first 2 are mandatory, the third is optional. So the first step is a multiple choice test. The second, the day after, is a written exam. Typically with 2 exercises. There is a study of a function, plus study of a function plus theoretical exercise. Okay, you have to pass the multiple choice test in order to go to the written exam. And when you pass also the written exam, you pass the exam. But if either me or you want to improve your grade, you can try the oral exam. But remember, the grade at the oral exam can be lowered. Okay? It can raise, but it can go down too. So try the oral exam only if you feel strong, also in the theoretical part of the course, not only in exercise, not only in doing computation. I will ask you proofs at the oral exam. Okay? Don't underestimate this point. It is very important. And so I will be more precise when I will have further information on section and on the grades of the exam. And so this is basically all for what concerns this introduction now. And so we will go to the first argument. First argument I told you, which are the elements of logic. Okay, this is basic. I will not ask anything of that at the exam, but it is very important for you to know something in order to be more aware of what you are doing when you reason in mathematical terms. So, elements of logic are the following. First, we talk about propositions. Propositions are statements. This is a sort of informal definition. A proposition in logic is a statement that can be evaluated as true or false. Okay? What does it mean? It means that it has to be a sort of objective statement. For instance, if I say something like Rome is the capital of Italy, okay, this is true. If I say Rome is beautiful, okay, I think everybody agrees that Rome is very beautiful and it's extremely beautiful town, and I invite you to go to Rome if you are here in Italy from abroad and you never visited Rome, because it is an experience. But, however, there could be someone who has very strange taste and say, I don't like Rome so much. I like more, I don't know, Vercelli. This is a matter of taste, okay? I cannot, I can disagree, but I cannot say you are wrong. Because it is not an objective statement. So you cannot give to this statement an evaluation like true or false. This is not a feature for this statement. So this is not a statement for our logic. Of course, the proposition we want to treat are not so simple, like there is a subject, there is a verb, and then there is some feature to be verified. They are not so simple at all. We have to add something more. For instance, if I say Rome is the capital of Italy, and I say Paris is the capital of UK. You immediately see that this statement is more complicated than the previous one. This is a sort of union, of connection of two statements of the previous type. The first is this: Rome is the capital of Italy, and the second is Paris is the capital of UK. Okay, but this is a unique statement which is made of two pieces. I told you they are connected, and the connection is made through this and. Okay, this is a logical connective which is called and. Of course, there are other connections. For instance, you can put it or here. And then it is very different, okay? Now I have to interrupt one meeting because I don't want to give you too long files because they are very, very difficult to handle for the system. So I give you this question. Think of it in this minute between one video and the other. The question is, is the statement with the logical connective and true or false? First. Second, is the statement with the logical connective or true or false? Okay? Okay, let's go to the other video.